so what's negative 2 times negative 2? 4 plus 3? 7, yep. Okay, negative 2 times negative 1? 2 plus 3? Yep. Negative 2 times 0? 0 plus 3 is? Negative 2 times 1?
Negative 1.
Negative 1 plus 3? Nope. Nope. Negative 2 times 1. Negative 2 times 1.
Negative 2.
Negative 2 plus 3.
1.
Negative 2 times 2?
Negative 4.
Negative 4 plus 3?
Negative 1.
Negative 1. Yep. So then plot those points. Plugging it in for the x. All these x's. Like plugging the negative 2 in, then the negative 1 in, and so on. This is what we did in 3.1. So look back at 3.1, like the second page with all the graphs, and then you'll remember.
How do you even see this?
I don't. I just feel it in my soul. All right. And then connect the dots and put arrows on both ends. All right, and then the second one's absolute value. So what's the absolute value of negative 4? 4 of negative 2?
Negative 2. Oh, wait, no, 2.
2, 0. Oh. Of 2?
2.
And of 4.
4.
Mm-hmm.
Absolute value is how far away.
It's the distance, yeah.
Yeah.
Yeah, distance from 0. Yeah. So it's absolute value, though. Because remember, absolute value is distance from 0, so it's always positive. So it's not like, this is just absolute value of x. Not like 1x. It's like these are absolute value bars. Yeah. Yeah, so anytime there's a space between the x and it, then it'll be absolute value. Okay, so that graph is going to look like this. All absolute value graphs are going to be a V. Okay. The reason why is because the parent function that this is based off of, so just y equals x, that's like the most basic y equals mx plus b you can possibly get. That's this line right here, but it would go like, it would continue going into like the negatives. But since it's absolute value, basically what happens is as soon as it starts to go negative, it bounces and like reflects off to stay positive. Okay. All right. So we are just doing linear versus nonlinear patterns. So your objective is, second. Okay. Students will be able to distinguish between linear and nonlinear patterns from equations graphs, tables, and situations. Okay, I'm just going to kind of break it up like that. So we're going to go through, and for each of these types, we're going to talk about, like, how do you know if it's linear versus how do you know if it's nonlinear, okay? So later when we're doing the examples and we get an answer and you say, how do you know? This is how we're going to know, okay? So, graphs. If you're looking at a graph, linear versus nonlinear is very easy. A linear function is going to make a straight line. But it can't be vertical, okay? But whatever, it's never going to be. Nonlinear is going to be not a straight line. So everything else. So your but like U-shaped ones that we did, those are cubic graphs, those are absolute value graphs, anything that's not a straight line. It can be like have straight lines as part of it, but not like a continuous straight line. Okay, so that's linear versus nonlinear. Equations. So if you're just looking at the equation, your linear ones are going to be in the form y equals mx plus b. And like you don't have to have all the pieces. Like y equals x is y equals mx plus b. It's just the most basic form. Okay, and nonlinear is going to be everything else. So so not in the form y equals mx plus b. So nonlinear is going to include anything with an exponent. Bless you. Absolute value. Anything with like a square root or anything in it, okay? So it has to be just like x to the first power, no exponents, none of that to be linear.
Whoever came up with the idea of extending
All right, and then on tables, the values that you care about on tables that are going to tell you linear versus nonlinear are the y values. So for the, like the x values are going to be like going up by 1 or up or down by whatever, but the y values, like what you're getting after you put something into a function, what you're getting as the answer is what's going to tell you. So linear is going to be, so for the y's, it's going to be a constant add or subtract pattern. So for the y values, you're adding or subtracting the same number every time, and that's going to be linear. Okay. For nonlinear, it's just going to be not that. Okay. So it does not have a constant add or subtract pattern. It doesn't have to have another kind of pattern. It doesn't have to be like multiply or divide or anything like that. It either is or it isn't kind of deal. Okay? Because nonlinear is going to include a bunch of different types of functions, and they all have different patterns in a table. So you're either saying, am I adding or subtracting the same thing every time for the y's? Yes or no? Yes? Linear? No? Nonlinear. Okay? Good? All right, so let's look at problem 1 at the bottom. Oh, and then here, if you aren't sure about an equation or a situation, make a table of values and look at the shape of the graph. So let's say I have a table and I can't remember how I was supposed to be able to tell that. Plot the points. Doesn't make a straight line. Okay? All right, so problem 1. The graph shows the relationship between the number of rectangles and the perimeter. Based on the graph, is the relationship linear or nonlinear? So based on the graph, would it be linear or nonlinear? Linear, why? Huh?
Because it's going up at a constant.
Yep, it's going up by a constant rate, and then how else could I just visually see that?
It's a line.
It's a straight line, yep. And then you guys do the got it. All right, is linear or nonlinear? Nonlinear, why? Yep, not a straight line. All right, good? All right, so for the tables, get a calculator. The area A in square inches of a pizza is a function of its radius R in inches. The cost C in dollars of the sauce for a pizza is a function of the weight W in ounces of sauce used. Is each table linear or nonlinear? So we care about the outputs, right? The Y values. Not what we're putting in, what we're getting out. So we're just looking to see what we're adding or subtracting every time and seeing if it stays the same. So going from 12.57 to 50.27, figure out what I'm adding. I think it should be 37.7, right?
Yeah, there's 7.7.
So plus 37.7. Now figure out going from 50.27 to 113.10. What do we get?
87. Wait, for what problem?
So going from 50.27 to
I thought
113.10.
you said 201.
What is it? 62.83?
Yeah.
Okay, so is that going up by a constant amount?
No.
No, so this is going to be nonlinear. All right, and then here, for this table, so this is your x, this is your y. So looking at our y values, going from 0.8 to 1.6, what am I doing?
You're adding 8 cents.
Okay, and then from 1.60 to 240,
Also adding 8 cents.
does that continue all the way through? Okay, so linear or nonlinear? Linear. Yep. Good. And then you guys try the next one. All right, so here, what are we doing going from 512 to 509?
3.
Are we adding or subtracting? Okay, so minus 3, and then 509 to 506. Subtracting 3, and then does that continue?
Mhm.
Yes, so linear or nonlinear?
Linear. Linear.
Yeah, because it's a constant. And so it has to be constant after subtraction linear. Because if you're thinking about like a graph, it would basically be going, every time you go over one more, it'd be going down 3. So like down 3, down 3, down 3, so make a straight line. Okay? All right, problem 3. A band allowed fans to download this new video from its website. The table shows the total number of downloads after 1, 2, 3, and 4 days. Which graph could represent the data shown in the table? Okay, so here's my mindset. Is it increasing or decreasing? Increasing, right? Over time it's increasing?
Yeah.
So what can I eliminate?
D.
D, because it's decreasing. The rest are all increasing. All right, so then here, let's figure out if this is linear or nonlinear, okay? So going from 346 to 1011, what's that?
665.
Plus 665?
Yes.
Okay. And what about the next one?
2,444.
Okay, so is that linear?
No.
No, so we know this is nonlinear, so which other one's that? A. That's because that's curved. So this is nonlinear, so A has to be out. So that A is a straight line. So then here, the difference between B and C is that you have on B, it's like as you move, the amount that it's increasing is increasing. And then here, it's kind of leveling out so that it's not like going up a ton as you get later in the number of days. So which one is more like this one? B, yeah. Because it's like picking up some momentum, right? Mm-hmm. Hmm? Oh, 2,444.
Yeah.
Got it. Okay. Yeah, there. Thank you. Okay. All right, any questions on that? So do the next one. Be very careful. Think about it. Look at it. The table shows the amount of sunscreen left in a can based on the number of times the sunscreen has been used. Which graph could represent the data shown in the table? Okay, so first this is linear or nonlinear. So it's minus 0.2, right? Minus 0.2, minus 0.2.
How do you get 0.2?
By doing 5 minus 4.8. Yeah. Or you could do 4.8 minus 5, either way, then you'll get the negative 0.2 that you need. So this one's going to be linear. So which one's out? B. What's the difference between A and C? A goes all the way down to 0. Does our table go all the way down to 0? No, so which one does it have to be? C, yeah.
Wait, did we go over the answer to problem 3?
Yeah, it's B.
Do we have to write linear?
No, that's just like notes to help explain how we got there. Okay, so now for equations, remember that it has to be y equals mx plus b to be linear, and then otherwise it's not. So what do you think for the first one? Yeah, nonlinear. Y. Yeah, it has an exponent. Okay, what about B? Linear. And C. Nonlinear Y. Because what? Yeah, exponent. Okay, go ahead and do the got it. All right, A, what'd you guys get? Linear. Yep. B, nonlinear. And C. So this is actually absolute value. So nonlinear. Huh? That's the value. All right, so for situations now, we're looking for if as you're moving through whatever the x's are, so if it's days, like every day, as you're moving through that, whether it's like adding and subtracting as you move along or if it's multiplying and dividing, okay? So for the first one, you get paid $5 for every lawn you mow plus $20 in tips each day. So every lawn, what's happening? What am I doing? You're getting $5. So is that what operation? So you're adding $5 for every lawn, right? I'm not even writing an equation for this. So the fact that it's adding tells me it's what? Linear, yep.
So if it's subtracting, it's wrong.
No, it's also linear, yeah. Yeah, it's when if it's like multiplying or dividing is when it's not. Okay, the branches on the tree triple each year. Yeah, nonlinear because what's tripling? So it's times tripling times 3 every year, right? So since that's multiplication, that's what makes it nonlinear. I know that can be confusing. What confused me about this was that I was like, but we are like in the equation, it's 5x, like it's 5 times whatever x is. So that would confuse me because I'm like, it's multiplication. But that's if you're using the equation. That's not if you're thinking about like what's happening in the situation. Okay, so don't think about the equation. Yeah. No. Your new puppy gains 2.5 pounds each week. Yep, so it's plus 2.5 each week. So that's going to be linear. Are we done or do we need a minute? Done? Okay. The distance from the center of the field as a football player runs from one end zone to the other. This one's tough.
Oh, you said non-linear, right?
I don't know. Think about it. So we're on one end zone, right? We're talking about distance to the center of the field. So as I'm running, what's happening to the distance?
It's decreasing.
It's decreasing, right? So the distance is going down as I'm getting closer to the center, right? But then what happens when I run past it?
Then it adds
It goes back up, right? So if it goes down and goes back up, what is that?
absolute value.
Absolute value. So this is going to be nonlinear.
Yes.
All right, the area of a piece of paper each time you cut it in half. And it's going to be nonlinear because it's cutting it in half. That's division, right? A movie streaming service charges $10 a month plus $2 for every DVD you rent through the mail. Linear, yep, because you're adding $2 every DVD.
Would multiplication be linear?
Yes.
I was confused about that one because wouldn't months also be a variable? That's all I thought.
So yeah, if you are no $10 a month, so this is going to be like in the realm of 1 month. So you're paying $10 no matter what for membership for that month plus the DVDs.
It calculates.
Yeah, that ones like that always mess me up too.
Curious though. If the months were sorry, it's tired.
Hmm.
If months were a different variable, would it still be linear since the two variables could change independent of each other?
Yes. So what basically would be happening there is that you would have a linear function, just it wouldn't be in y equals mx plus b form, it would be in standard form. So you'd have like let's say the months were x and DVDs were y. You wouldn't have this equaling another variable. You'd have it equaling like a cost. So either way, like y equals mx plus b has x and y in it, and that would also it's just ordered a different way. Does that make sense? Okay. Here's your lesson check. I'm gonna switch it over to my computer because it's on there instead because it has like pictures and stuff. And then I'm gonna just cut the video off really quick. So sorry if you're watching the video, you don't get to do the lesson check. Bye.